Well, hello folks, I am Watchman, and this is my 2-digit decimal display. It is right now just a counter, just a clock, counts from 0 to 99, and then wraps around to 0 again. Um, it's just, the only thing different about it is that, well, it's a 2-digit, and I haven't seen any 2-digit clocks before, and I took a little care in the way I built it, and kind of wrapped the logic around here to the front, and put it all kind of out and displayed it nice and clean for a couple of reasons. One is to make it run a little smoother and make it a little easier to understand and debug. The other reason is, I mean, it just looks really cool. I mean, that's pretty awesome. But anyway, we'll go ahead and watch. It should wrap over here. It should go to 50. Yep, 51. Yep, so yep, it's working. The displays are fairly simple in their construction. It's I've got a torch on every other block going around. They are 8 by 16, I believe. The construction is just I took and put redstone out the back side of each of the blocks with a torch, and just connected them all together. Kind of just chained them together here, and then run through a repeater and down to the ground, and that's pretty much the same for all of them. And then for the horizontal segments, I just took all the torches there, run redstone at the back, and then run all those down to an inverter. So then I've got 7 inverters here. They all get connected together and compiled, I guess, into this data cable or data bus or whatever you want to call it. It's got 7 lines on it right now. That's 7 wide by 2 tall, 2 lines tall. So I can still maintain my every other piece. So if you dig down here, there are actually, took a piece of redstone out. They actually are every other one. There it is. No. Okay. So you put those on there. It isolates them. The torches, you can only put an inverter in here if you put one on every single line. So there's one under that block, one under that block, one under that block, and by putting them all side by side, they won't interfere with each other, and they'll stay as separate lines. So I would just put a set of inverters in every 15 blocks, and gone around underneath this giant obsidian splash guard, I guess. Somebody went and put cannons up right over there, and I was kind of scared that a TNT would go flying off and blow a giant crater in my work, so that'll protect most of it. But anyway, this is another one. It's identical for the other display, just a mirror image. It's a little more organized and methodical in its approach, but it does the same thing. It assembles it into a 2x7 or a 2x4 matrix, I guess. Every other block with all 7. So that means this is now 14 lines total coming down the hill here. I've got a couple of inverter stacks there, and then I pull off of all of this. I pull the top 3 off and send them straight down, and then the bottom 4 I send over to create a nice 7 line structure for my drivers. And I do that twice, once above, and if I drop down here, I do it again below, So this is the second display. And then I've got, I use the driver that Harbinger had in one of his videos. It's just a super simple driver. I like it. It's easy to build, easy to configure for the different letters, and it's just very clean. So I've used that everywhere. I got 20 of them total, and on the other side I have a matching 20 gates. I've got a set above and a set below. These are all virtually identical. They're 4 input AND gates, where you've got to have all 4 inputs low to get an output. And then to make them different from each other, I've put inverters on the input to the gate. So I've got those two are both inverted, those two are not. Here for number 2, I've got the top 2 inverted, the bottom 2 also inverted, and that would be a binary 2, that would be a binary 1. It doesn't exactly make sense because of the way I'm taking off of the way I'm transmitting the binary code, which is in 4 digits, one there, one underneath that block, one there, one underneath that block. So it's in a row of 4. I'm pulling off, some have inverters, some don't. Some come pre-inverted, so I'd have to put another inverter here, and so that doesn't really make sense, but it that's the way it has to be done to make it fit nicely like this. Yeah. So anyway, after I come all the way to the end of that, I've got all 10 of those gates. Then I've got where I pull all of these out of this pipeline here. I pull all these redstone out to 4 repeaters, and then from there it goes into one of 4 data type or D-type flip-flops. Each one is strung with its input, or with its output being the input of the next, so they're just kind of daisy-chained together. Each one, basically in function, it just cuts the clock speed in half. So you've got a clock coming in, which is this torch here. This gate cuts it in half. This gate cuts that one in half, and this cuts the half in half, and this cuts that half in half. So that ends up creating the binary signal, and it just counts from 0 to 15. I've got a reset mechanism, which is this guy over here, and what I do is I pull this off of the number 10 gate, so that as soon as it hits the number 10 gate, this will activate and it will reset all of these latches, and reset all of the counters, all the flip-flops back to 0, and restore the 0 on the counter up there. So it just kind of short circuits it, I guess, and starts things over. This is an identical set of 4 flip-flops. This is for the 1's place. The ones I showed you earlier were for the 10's place. And then this is the clock that drives it all. It's a giant 25 torch inverter ring that just creates a long, slow, lazy pulse that drives everything. So anyway, there's that, and that is the clock. Oops. Nothing earth-shattering. It just looks a little different. It's operationally the same as any 1-digit clock. I've just got 2 of them literally stacked one on top of the other, and no, just went from there. So there it is. Thank you for watching.